What we'll be looking at here is object-oriented programming in Python via a simple example where the highest level class is something we'll call a chain, where a chain is basically just a wrapper around a list, where the list inside that chain will be in the property called links. Okay? So links will be the traditional list in Python. And then we want to treat that chain in different ways depending on our application. So we might want to treat it like a stack, maybe treat it like a queue, and maybe like just essentially a list or an array where we have direct access to any point in the chain. Or we might want to treat it like a wraparound list. So when you get to the end, you just wrap right back to the beginning. So all of these will be handled in the next simple example. And here's the code for dealing with that. In Python, when you want to use objects, when you create classes, you just use the class statement and then the name of the class. In this case, chain, and you normally capitalize the name of classes. Your colon there, and then everything associated with this class then will be indented relative to the class name. So here we have this class chain, and then we start with the subclasses down here. So for every class that you create, you need to have an instance for actually initializing an instance of the class, and this is your init method. And it always has 2 underscores, the word init, and then 2 more underscores. The first argument is always self. This will refer to the object itself that you create, and all methods all of the instance methods for a class will have this self. Notice here all the methods, you define them with def, just like you define a function. All of them have self as the first argument here. We also have something called class methods associated with the class. These are not as common to use. You don't use many of them usually. We'll go into that a little later. Okay, but the main methods are down here, these instance methods. We also do, for the chain, we have one class variable. This is a variable that is associated with the class itself, not with each individual instance. I showed on the previous slide that each chain will have one property called its link. Here is that link. It's set in here. Typically, when you have different instance variables in Python, you will initialize them in this init routine. I personally like to, even if I initialize them to nothing, I like to have them in the init routine just so I can see all my property variables in one place. Other people like to include large comments up here that describe each property variable and possibly each method in the comment. Or over here in the command window, we can see how we do that. First, we had to import the file, which I also called chain, importing it into Python. And then we create an instance right here. We say C, some variable, is equal to a chain, a call to the chain class, which creates an example, and an instance, and then the first argument to the init routine. The first argument to the init routine, besides the self, which you typically don't see in the argument list itself when you make the call, is the init link. So the initial list of items is passed in here. Okay. So we have this variable C, and now we evaluate C. We want to know what it is. It tells us that it's a chain object, which is defined in the module, also named chain, and this gives some information about where it is in memory and so on. Okay. We can then type the word type, and then C is the argument, and that will tell us the type of that object. Okay. And now we look at some of the methods that we've defined for our class for a chain. We can get the links, so we can look at what links it has. Example. Okay. We can pretty print it, which just shows each item with its index 0, 1, 2, 10, 20, 30. And we can add elements to it. Oops. Okay. And we can pop meaning remove the last element. We can even join it with another chain. So for example, we can make a copy of this one. C2 equals C dot copy. And then we can do a join of C with C2. Now we have a double list, basically. The copy routine, if you notice the copy routine here, it actually takes advantage of this call to the type function that we used up here. The copy routine actually will take any object of any type, not just of type chain, but maybe of one of the subtypes. It takes it in and creates another example of it. And it does so by first calling the type function on the particular object, finding out what it is, what its type is, and then using that type returned, for example here, this class as a function basically to create a new one of the same type. And here are the initial argument is the links or the little internal list of the particular the original object. So it's a very, very useful technique here when you want to create new instances of something, but you don't know its type. You can just call the type function, get the type, and then use that type to create a new instance. This pop method to remove the final element in the chain. Okay? So pop is defined at the chain level. If we now want to treat our chain as a stack or a queue, we can maintain that same pop method. We can use that for both. All we need is a push method, and we have to define that differently for a stack versus a queue. For a stack, we're going to do our pushing onto the end of the chain, and that we can do with a call to add, which is we defined up here. Add would always just add a new item to the chain, as long as that wouldn't put us over the maximum size that we've defined for our chains, which here we just arbitrarily assigned it to be 100. Okay. So the push routine for stack adds it to the end. The push routine for the queue is the opposite. It just inserts the new item at the very start of the list. Okay. That's the only difference between a stack and a queue then, is the way you push. The way you pop is the same. It's always going to pop off the back end. And of course with the stack that means last in, first out, but with a queue it'll be first in, first out. We can create a stack and just create an empty stack if we want. And then we can push a few things onto it. See what we got, and then pop something. Okay. And then we can do the same thing for a queue. In this case, let's initialize it with whatever we got from the stack, the values of the stack. So we'll initialize the queue to be the links of the stack. And now we'll add something to the queue. And notice that was pushed onto the front of the queue. We got the two values from the stack as our new values in here, and then we pushed on something new. And now, of course, we're going to do a pop from the stack. Oops, from the queue. It also popped it from the end, so we still got the 444 in there. All right, so now if we want to look at our chain in a way where we can sort of have random access to any spot in the chain, not just the ends, we create a different subtype called the series. A series then inherits from chain, as did stack and queue. Okay? And it has one extra property variable. It's called the current location. We talked about earlier. We initialized it to -1. Notice here in all the initialization routines for the subclasses, for stack, queue, and for series, we're actually calling the initialization routine for chain. Okay, and here's the syntax for doing that: is we write the class, so the superclass, the init routine, and then the first argument in that call is actually the object itself. All right. Now, in most calls to methods, you don't actually see the word self in the argument list. You typically see self in the beginning. So, for example, out here, if I were to make a call, and just to show you what it looks like, I might do self dot delete or something like that to delete an element. Okay. It's only in other languages, sometimes you would write something like delete with self in the parentheses, but typically you don't see self inside the parentheses on a call. But this is an exception. Okay, when you're calling the superclass, you type something like this, and there's self inside the argument list. Okay? So slightly different syntax. Just be aware of that. So essentially, this init routine for a series is a wrapper, wrapping around the call to chains init. And there was one more thing we needed to do, and that was declare this extra variable, or curloc. Okay. For the series, then, we want to have access to any item, so we can insert at any point in the list. We can insert a new element, or we can delete from any spot in the list, or we can overwrite a particular spot in the list. So these are all just basic routines that we're creating for the series subclass. And then if we want to, and then we have this next routine, which allows us to iterate through the series. We'll look at the basic difference between a series and a ring then. If we create a series here, just a few values in it. And then we iterate through it by asking for the next value, next value, next value. When we get done, there's nothing left to return. Okay? The series just goes to the end and stops. Whereas if we create a ring instead, and we'll just give it the same values as we had in the series. That's s.links. Okay. Now when we ask for the next object in the ring, notice at this point we ask for the next, and we go back to the start, and we just keep looping through. Okay. So that's the only difference between the series and the ring, and you can see that there's not much difference in the code between the two. It's only this next routine that's different. The next routine in the series, once you get to the maximum, it essentially just returns nothing. Whereas for the ring, you use the modulo operator to, once the current location gets to be equal to the actual length, then the modulo will just set it back to 0, and you just continue on. In a class, you have your instance methods and your instance variables like links and current location down here. You also have class methods and class variables, and we talked about a little bit. The class variable for this chain is a maximum size, which just says no chain can have more than 100 elements in it. Okay? And you also have class methods. Now, it's not that common to use a lot of class methods, but just wanted to show you the basic idea here in case you do want to use them a little bit. For example, here we have this class variable. If we wanted to define an accessor function or accessor method to that variable, we could define it this way: define and then size limit. And notice this method does not have self. All the other methods have self as their first argument. You call the chain class itself, okay, with the method name size limit, and there you get back the size. Okay. And notice in the method itself, all you're doing is accessing this class variable, and to access it, you have to have the name of the class first. We could access that from out here too, if we wanted. Okay, so that's one such class method. And notice that class methods, a lot of times in code, they'll write this ampersand static method ahead of it. This is sort of window dressing or a decorator just to remind us that this is a class method, and that's why it has no self in here. Okay. Here's another class method where I didn't use this decorator. It still works fine. We'll call this make. Okay. Now notice when we created a chain before, up here, we just did C is equal to chain and then our initial value. Okay. Well, another way to do this is right here. We created this method called make. So we could call the class chain, we call it the method make for that class, and then we give it these initial arguments. And that will also give us a chain. Okay, so this is really just an example to show what you can do with this. There's really no reason to actually write a make routine for this simple class. But in general, this idea of a class method can be useful at times. And as you see, the syntax for it is very similar to a regular method. Okay, we're going to talk a few minutes about the concept of operator overloading in Python. Let's look at a simple example here. Let's say I create one chain and I give it just a couple items here. And I create another chain and I give it the same items. And now I want to just ask, I've got these two chains floating around in my program somewhere. I want to ask, are they the same or not? Well, I can just type the equality sign, the equality test, and get an answer back. Okay? So I'm using my basic arithmetic operators, the Boolean and arithmetic operators. I'm using them with a more complicated construct with a chain. Okay? The trick is here that I can define equality for chains. Okay, for the chain class, I can define what equality is. I can also define what greater than is. I can ask, is C1 greater than C2? It doesn't give me an error. It just says false. It's not. And it tells me they're not. Okay. So how do we set this up so that we can reuse some of these basic operators for more complicated objects? Okay. And this is the concept of operator overloading, where take this basic operator, but it's overloaded. It has many different meanings, okay, depending on the context, depending on the classes it's used with. So here's how we overload these operators in Python. Here we're within the class chain, and we're defining now 5 new methods. And each of these is meant to overload a particular operator we normally use in Python. Okay. If we want to overload the equality sign, the double equal, or the equality test, we do that by redefining or defining the function eq, 2 underscores eq, 2 more underscores. These are standard names that Python recognizes and will immediately map these to these standard symbols we use. So we're now at this level, we're defining equality for something of type chain. And we're saying a chain 1, let's say, is self, and we're comparing it to another chain, C2. And here's what it means for those to be equal. They have to be of the same type, so we ask of the type of both, and their links have to be the same. And for their links to be the same, this is actually another overload of the equality operator, because for 2 lists to be equal, this is defined as going through the lists, both lists, and checking each corresponding item in each list and checking whether they're equal or not. So this operator, the equality operator, has already been overloaded for us by Python, which tells us what equality means in terms of 2 lists. We're piggybacking off that notion of equality and encapsulating that in our new definition of equality for a chain, which of course is just a wrapper around the list. So this makes perfect sense to do this. We can also redefine the greater than operator using this underscore underscore gt underscore underscore. And now when we compare self to another chain, C2, we just ask the question of whether the links of self are greater than the links of C2. Again, greater than has been overloaded for us. It's been defined for lists, and so we're just using that. 2 lists, one list is greater than another. If, for example, if you compare the first 2 elements, and if the first list has a 7 and the second list has a 4, then the first list would be greater than the second list. So it's an element by element comparison until you find two two corresponding values that are not equal. At that point, you can decide whether one is greater than the other or not. The str method for string is the method for converting a particular object into a string representation of itself. And we can define that for a chain as basically being a call to the standard string function where the argument is the list of the links. And as it turns out, the string function has also been defined for a list, so that when you type string around a list, for example, we can just set x equal to some list. Right. And if we ask the string of that list, it returns that list in quotes. Right. So we're reusing this. This already, the string has already been overloaded in the sense it's used now for lists. We're reusing that to define the use of string for a chain. REPR, representation, is somewhat similar to string. This is saying when I actually type in an object's referent at the keyboard, so here when I type in C1, what gets returned? How do I print that out? How do I show that? And we've defined that here in this way. We've said when you want to print out something, when you want to evaluate an object type chain, what you do is first you type the type, which could be a chain or one of the subtypes like stack, queue, ring, so on. Then you type the keyword links, colon, space, and then the links themselves. Okay. And the links themselves, it's not obvious here, but this is a call to our string method. This will end up being a call to our string method because of what we defined here. And that will print out the links. So here's what we get when we type C1: the class, the keyword, and then the contents. Right. And finally, we can overload the addition operator. Okay, we can just take a regular plus. What happens when you write chain 1 plus chain 2? Okay, you get a chain that's essentially been the first chain. With the second chain added onto the end of it. That's just how we define a plus for chains. It happens to be the same way that plus is defined for lists. Okay, here you see the two links for the two chains. Those are combined in the same way. You just append one onto the other. In this case, we just created a new chain with the combination of those two links. Another example here, we have a stack S and a queue. They both have the same contents, and now we can ask, is the stack equal to the queue? And the answer is false, because remember how we defined equality. Not only do they have to have the same elements in their list, but they also have to be of the same type, and these are not of the same type. Okay? We could also ask, for example, a little more complicated Boolean expression: is it true that S is not greater than Q? And that is in fact true. You cannot show that S is greater than Q. Is Q greater than S? That's not true. And then we can add an element onto the Q. And now when we type just the letter Q, the evaluation of that returns this statement, the string, which is how we defined it down here. It returns the type, the keyword links, colon, and then the contents. So type, links, contents. And we can do the same for the stack. We can now ask, is the Q greater than the stack? And now in this case, the answer is true, because the Q begins with the 4 and the stack begins with the 1. So this is greater than this. This list is greater than this list. Right. We can ask for the string version of the stack. That just gives us the contents in quotes. We can also ask, we can create a new chain C, and another chain, call it C2, where chain 1 has I am Sam, chain 2 you are Sam, and then we ask, is C less than C2? And that's true, because the Y in you is greater than the I in I. When it compares these two words, this word's greater than this, so C is less than C2. So several different things we can do when we decide to overload some of these common operators.